Hey guys, I'm Joseph Barnett, and my invention isn't nearly as scary as Carl's. But anyway, I'm one of the inventors of the NeoVent, which is a device, it's a low-cost device used to treat infants with respiratory distress. And Stephen, who's the other inventor, he's not able to be here today. He's in Nepal for the summer, working in a hospital, but we have a video of him, and he'll talk in just a few minutes. And so there's the NeoVent is what our device is called. And I'll start with what motivated us to invent this, and that was our time abroad. There's me in a Jeep. I'm proud of that picture. I really like it. And there's Stephen right there in the hospital in Nepal, and that's his father. He works as a pediatrician there. But for the last 5 summers, I've worked at a hospital in Honduras, and I've really enjoyed my time there. I've learned a lot of stuff. I've been able to teach in the school and work. I've repaired jungle water systems and worked in a clinic and all sorts of things. And similarly, Stephen grew up near a hospital in Nepal, and his father was a pediatrician and his mother was an engineer there. And so through these experiences, we were really able to see a lot of the healthcare disparities that exist between the first world and the third world, and we wanted to do something about that, but we were just high schoolers, so we didn't know where to start, and the most logical place seemed to be to get a degree. And so we started our pre-medical studies at Western Michigan University, and in 2013, we got a call from a respiratory therapist named Eric Chang. And what Eric told us was that a lot of infants in developing countries are dying of respiratory distress because the hospitals they're being treated in don't have the tools that they need to save their lives, essentially. And so in respiratory distress, what you have are lungs that collapse because your lungs are full of millions of tiny little balloons. They're called alveoli. And so in respiratory distress, these alveoli are really prone to collapse. And if they collapse, your whole lung will collapse, and then the baby can't breathe and you die. And so in these circumstances, what you typically need is a type of treatment called bubble CPAP, and that's delivered in a lot of developing countries and places like Nepal. It stands for Bubble Continuous Positive Airway Pressure. And what it does is it delivers one level of pressure to the infant through nasal prongs or a mask, and it keeps the lungs open. And so that's very helpful, but for infants with moderate to severe respiratory distress, they need an additional treatment, something that would be dual level. And you can kind of see here, it would be a low pressure and a high pressure and a low pressure and a high pressure. And so that facilitates the infants being able to breathe down at the microscopic level at the alveoli. But in the US, they deliver this with ventilators or BiPAP machines that cost thousands of dollars, and so it's not a viable option for many hospitals in Nepal specifically. And so what Eric asked us to do was to design something that would be not only affordable for hospitals around the world, but easy to operate for the nurses without the discipline-specific training of a respiratory therapist. And so that's what we've been working on for the past 2 years, and what we've developed is a very low-cost solution that's easy to operate, and it actually is an attachment to the bubble CPAP setup, which is very common around the world. And so all you have to do is attach our device to their existing setup, which will deliver the next level of treatment. And so it's also powered by the bubbles of the bubble CPAP. And so it's very neat, and Stephen's going to talk just a little bit more about that. But in the meantime, what I'd like to leave you with, and I think what everybody's kind of been saying this whole time is, I'd like to stress the importance of hard work in not just invention, but in all areas of life. You guys are mostly high school students, and in the next 4 to 8 years, you'll become engineers and doctors and teachers and nurses and inventors. You already are inventors, but the important thing to do is to work really hard, but to couple that with your passion. You can work really hard at something, but you won't be happy about where you're at or be able to succeed if you're not really passionate about it. Stephen and I are really passionate about this project, not just because of the science behind it, but also because we're passionate about the health outcomes for all the people that it will impact. So I'd encourage you not only to work hard, but to be passionate about that and find your passion first. Thank you. And now if we could pull up the video of Stephen.
So sticker babies require a dual pressure treatment in which you have a high pressure and a low pressure, and a high and a low, high, low. You go back and forth. And unfortunately, unlike for CPAP, there's not a convenient bubble system in which you can deliver this very simply at a low cost. The result is that you have over 1 million neonates dying due to respiratory problems. And so that's how a respiratory therapist would see the problem. As an engineer, we see that we have to design a low-cost, easy-to-use, bi-level system that or bi-level pressure system that works off of the bubble CPAP setup. So how can we do that? And so we started off just on paper, thinking of all the different crazy ways we could possibly make something that might work. And I think one thing that's really important is when you're at the very beginning, you've got this problem that's well-defined. We need to solve this. We need to make a device that provides a high and a low pressure with the bubble CPAP setup. You think of all the different ways that you could do this, and you talk to other people, you get their ideas, but at this point, nothing's out. Any idea is valid. Then the next step is where you build and test those ideas. And for us, we started off in a basement using whatever we had, little pieces of tin, plastic, from chapstick tubes, milk cartons, whatever. Eventually we moved into a lab, but you build and test those models, and as you build and test, you start to see, that idea is not going to work. We had a design with a little flap that was supposed to move, another with a rotor, and then one that we actually ended up using. And you see which designs will and won't work as you build. And I think the encouragement at this step would be to keep going, because it's very easy, especially as you're near the beginning, to think, you know what, none of these models works really well, but stick with it because some of them may. For us, about 2 years later now, we've got the NeoVent, and so its function, that inverted basket that you see there, captures bubbles, and once it's caught enough bubbles, it rises, it becomes light, so it rises. But once it's risen a specified distance, it reaches those windows, it vents all of that air, and so once it's lost the air, it becomes heavy again and sinks. So it kind of catches bubbles, rises, vents, sinks, does that again and again and again. That sleeve, or slider, that's moving up and down on the central pipe, covers and uncovers holes. So it's almost as if in the bubble CPAP setup, somebody is holding the pipe and moving it down for a second, and then moving it up for a second, and moving it down, and then moving it up. You're able to achieve this bi-level waveform. And the device is really simple. There's only one moving part. Because it's just 2 plastic pieces, we can produce it for maybe $25 instead of several thousands of dollars. And it requires no additional power because it's just using the waste energy from the bubble CPAP. And so for the nurse, once it's set up, it's just one connection to remove the pipe that was there before, connect in our device, and then hopefully they can deliver the next level of treatment. And these all sound like really cool little features, but these aren't peripheral features. For us, these were a central part of our design challenge. In other words, if any of these weren't met, then the device probably wouldn't be usable in places like Nepal, which is where I'm actually at right now. And so moving forward, we've formed a company. We're hoping to start clinical trials. That's part of why I'm in Nepal now. And I think for both Joe and I long term, we'd like to work as physicians abroad, designing medical equipment. So this has been a nice chance for us to sort of test the waters. And I think, just to recap over several of these points, and maybe what might be applicable to some of you all as fellow inventors, or maybe just getting started on that process, is that first you want to find a problem that you really think is worth solving, that could help a lot of people. And then once you have that problem, you start just with a blank sheet of paper and you list out all the potential ways it could be solved, even if some of them seem completely infeasible. I know for us, when we first came up with something similar to what we have now, it almost seemed a little too simple. Well, why hasn't anybody else thought of this? This is just one little plastic piece, this is moving. Surely if this worked, somebody would have already done it. You can start to second guess it, but no, at this stage you keep all of those ideas. You be as creative as possible. And then, of course, a very important step as engineers, we build stuff. So you build models of those, evaluate it, and at that building stage, just remember, what your problem is and how important it is to solve it. I think for us, thinking about all the babies who could potentially be impacted was part of what kept us going during this whole process. And then hopefully at the end, you'll have something cool that can help people. And so with that, I'll give it back to Joe for questions. Thank you.
And if so, can you just replace those in normal hospitals to decrease costs?
We measured the output of pressures, and yes, so it would be equivalent. It's not as, you can't deliver as many treatments, but for the treatments that we're trying to deliver, yes. I don't know that they would be replaced. So we're looking to do clinical trials, as Stephen said. So that's a lot of that is still to be determined, so if that answers your question.
Could you talk about going into communities that aren't your own and being, or understanding and being sensitive to those communities? I know that your partner is from Nepal, and may have grown up there, but I mean, you were in Honduras, and Could you talk more about that?
Yeah. So as far as when we test it, or the motivation for it, or?
Just sort of in general, I know that the previous presenter alluded to working on problems that aren't necessarily your own, and I think that has, in an increasingly global world, it has implications to understand the communities that you're working in. Okay.
Yeah, I would say, I guess the driving force for this was that time that we spent there and getting to know people who aren't from our culture and who didn't have the same problems that we have, and really, I think, understanding that and then developing compassion for these types of problems. Like we wouldn't face a problem like this, like in a hospital not having the proper treatment. So I'd say it was definitely a learning experience, and really was the driving force for this.
What's the durability of this device? Like, how long will it last?
How long will it last? We've tested it in the lab to run. It's run continuously for several weeks at a time. And typically, this treatment would be delivered for about 1 to 2 days. So it's very reliable and runs a lot longer than anticipated use.
You talked a little bit about how you thought the idea was simple, and how you thought someone would assume that someone would have thought about it. Would you talk a little bit more about your experience with that?
Designing it?
Yes.
Yeah. So that was one of the things that Eric asked us to do was when he kind of posed the question to us, could you design something? He said it needed to be simple. And so we started out with chapstick tubes and milk cartons, actually. And some of you saw my stand the other day with a Chobani yogurt cup. So that was one of our prototypes. So it's 2 moving parts right now. And so from the beginning, that's what we were looking to do. And we tried several different design iterations. We had 3 or 4, but this one was the only one that would actually worked. And so I had that at my stand as well. There are a lot of failed attempts, but you just keep moving, you keep building and doing your best. So, and I think we're out of time now. So thank you very much, guys.